ahead and get started real quick and finish up with our final session of the day. We'll be going into advanced air mobility infrastructure electrification. So with that, I have three panelists. I have Chip Palomini from Beta. I have Clint Harper from Harper 4D. And we also have Jeff Richardson from AFWorks. So welcome our panelists, and to kick us off, we'll have Chip with a short presentation and we'll go into the discussion.
Good morning, I'm Chip with Beta. I lead Beta's infrastructure team, so I can answer a little questions about the airplane, but everything that my team gets to work on luckily stays on the ground to support things that go in the air. So this is our aircraft connected to our charger. So we can certainly, I think there were some questions in some of the other sessions that Rex had mentioned specifically about the charger and some of the, or chargers in general, so we can certainly dive into that. When Beta started, our founder had a vision that there were three things required for electric aviation. That we needed a reliable electric aircraft, we needed a path to airman certification with the FAA, and we needed reliable charging infrastructure. The most successful electric vehicle company is the only electric vehicle company to have made significant investment in charging infrastructure. The reason, there are some analogs there and there's some differences there. We believe that their strategy worked, and the strategy worked because if people can't charge and charge reliably, they can't sell vehicles, nor would we be able to sell airplanes, and it would hurt their OEM model. So our drive and motivation to develop the entire ecosystem, including charging infrastructure, is to support the uptake of electric aviation. One of the decisions we had to make early on as we were starting to electrify airports is, are we making a Beta charging network or a charging network for the industry? And this is where we diverge from Tesla. Tesla's supercharger network was originally made only for Tesla to give them a unique advantage over their competitors. Beta's charging network is interoperable with many aircraft. So there certainly may be reasons that a certain operator or OEM could choose a proprietary connector, but we believe from an infrastructure perspective that interoperability will be required for ubiquity of electric aviation. What does it mean to electrify an airport? For us, it starts with site design and permitting. This is local permitting, permitting with the utility, permitting with the FAA. Then we actually have to start doing the work, so this is pulling three-phase power, installing new medium voltage transformers. A typical installation for us is about 5 megawatts, so it's very rare that we're going to a site that has an existing 5 MVA transformer, so at minimum we're usually going from three-phase transmission or distribution to a transformer. Then we're going to switchgear. This is where we come from utility transformer and start to distribute it to our gear. And then finally, we get to install all of the ground support equipment. One of the questions we get asked is, how do we decide which airports we electrify today? Typically, it starts with a customer need or a Beta internal need to operate in some geography. Then when we need to operate, like say we have a customer here, we have 3 airports that we get to choose from. We'll do a multi-criteria decision analysis. We'll look at things like availability of three-phase power, availability of other utilities. We'll look at runway lengths. We'll look at existing instrument approaches. We'll look at other facilities available at the airports. We'll grade them all. And then one of the things that we look closely at is the enthusiasm of the airport management, and the FAA for that particular location. Because even if we get a really high score on just some of these very quantifiable metrics. As we all know, sometimes if you want to do work somewhere, if everyone's not aligned and all the value isn't there, it can take really long. So usually we start with about 6 airports. Quickly, with the desktop review, we'll get it down to about 3. Then from 3, we'll consolidate down to 1. We're very fortunate in this country that we have, as everyone here knows, a lot of airports and heliports to choose from. Of course, there are certain locations where a customer may want to operate specifically at a airport, and then we have to operate there. I think there was a question early on about, and some people asked this about demand charges, about when do you put in a microgrid. Is everyone familiar loosely with the demand charge, difference between demand charge and energy charges, or anyone who could use a refresher on that? Okay, so at home, typically you just get like an energy charge on your bill, on your electric bill, right? So you get paid per unit of energy you're using, so that's your per kilowatt hour fee, which is your energy fee. For large commercial and industrial, so typically once you're over, say, 100 kilowatts of demand, so kilowatts is power, which is instantaneous, the utility breaks your fee apart into a demand fee and the energy fee. Typically under those structures, the energy fee is lower than what you would see on a residential rate, because the residential rate, they're blending demand, power demand and energy consumption together to make it easy for a consumer. In the larger power users, again, they're going to break the energy apart and the demand apart. Demand is usually assessed on a 15-minute peak power for the month. So if you hit that peak power of, say, for our charger, 350 kilowatts, one time in the month in Bentonville, you're going to pay $1,500 for that charge. That charge only occurs once, though, in the month. So you get to amortize that across the rest of your billing cycle. So that $1,500, whether you have 1 charge or 90 charges in the month, you get to start to spread across. So if you have very low utilization of a charger, the cost to charge becomes commercially not viable, right? Is anyone going to pay $1,500 to charge their car or their airplane? Luckily, though, once you get to only 3 charges a day, which when we think about UAM, AAM in the future, 3 charges a day is very low utilization of a charger. So once we look at how we spread and amortize the demand charge across charger utility, you can see, but once by the time you're at like really 70 charges, you're sort of asymptotically approaching this $50 or $42 a charge. So the irony here is that when we think about deploying microgrids and energy storage, the value proposition exists today because we can use stationary batteries to reduce this cost. But as flight operations increase, the value proposition erodes for microgrids and energy storage, which is sort of unfortunate. We can talk more about that, though, in the question and answer session. Where are we building out public access chargers? This is our 2023-2024 network that we're building out. These are all customer driven, so we do have revenue generation at some of these sites and other funding means for others, as well as beta capital supporting this. Really, we have customers who want to operate up and down the East Coast with electric aircraft, so we're deploying a charging network to support that. As time goes on, we'll add parallel routes here. Right now, if this was below IFR minimums, you're sort of stuck. So we're looking to add redundancy in the network. So we have customer operations that will be occurring on the East Coast. We have some disaster response operations that will be happening in the Gulf Coast. And then we have a connection from Burlington, Vermont down to Wright-Patterson Air Force Base for some of our work with Agility Prime. How do we control it all and command it all? We have a network operations center that monitors our chargers. This ratio of revenue to energy is artificially low because we have about 24 chargers at work that we let our employees charge on for free. So a good chunk of that 11 megawatt hours in 30 days is free charging. And if you did that division there, it's not indicative of what we're charging per kilowatt hour. But the great thing about this is we're processing, and this shows about 600, anywhere from 600 to 900 charging sessions a month right now on our charging network. though it's mostly electric vehicles. There is like ground vehicles. We do have some aircraft charging on there as well, but it's letting us bake out this entire network operations center, charger reliability, mobile app payment processing, the whole commercial end of it before we have true high volume aircraft operations. Getting back to the demand charge, we do have a method in here where we can manage peak demand at a single site. So in this example, it's a nice graphical interface. We can say the max at this site is 200 amps. This is Rutland, Vermont. We have 2 chargers on here. Each one's capable of 200 amps. So our system will monitor the instantaneous power at each of these and limit one. So that way the aggregate demand does not exceed 200 amps. We can assign priority to either a charger or a user, depending upon the business case there. The next step that we're iterating with is that this will become dynamic. This function right now assumes there's no other loads other than the chargers, but increasingly we're putting these at customer sites where there's another load that we don't necessarily have knowledge of, so we'll put a real-time power meter there that'll communicate with our control system, and this 200 will become a dynamic limit. And with that, I'll hand it over to who's going to go next, Clint?
Chip, thank you so much for that information. That kind of tees up the discussion that we're going to have. Try to get down in the weeds in some of these different challenges that we face in this particular part of the advanced air mobility when it comes to the electrification. So I'm going to start off with, when we look at the chargers and we look at the charging systems as a sense, what are some of the standards that we should be looking at when we see people designing these systems and these chargers? What is the benchmark that we should be using? Because we see a lot of people coming into this industry and it's like, oh, we're doing this and hey, we're doing that. It's like, okay, what standard are you using?
Sure, great question. So I'm also the chair of GAMA's infrastructure subcommittee. We released a white paper last month, or a resource paper last month on charging interoperability. That's really focused on the entry into service vehicle aircraft. And there we're using CCS that supports up to 500 amps of charging power or charging current. So that is the standard right now that the majority of the industry is building consensus on.
Jeff, any thoughts on commonality? I don't know if you doing some work in the AFWERX world. Have you seen it working, or do we need to work a little harder?
Yeah, so me and my team, we're in AFWERX, so we work for the Air Force. AFWERX is a subdivision of the Air Force, and we're trying to get these eVTOLs to the commercial market as quickly as possible so that we can leverage that for ourselves. We work very closely with Beta, and I like the CCS, and not to be a negative Nancy, but we're currently in the process of operating about 6 different eVTOLs by the end of this year. And I think out of those 6, we have 5 different charging standards. And I'm not in a place right now to make the requirement that you have to do a certain standard, so I have to make my charging very adaptable. So I certainly like the CCS, and I do know there are a couple of platforms that have it, but unfortunately right now in the market, it's kind of all over the place, and that's definitely a challenge from where we are. So we try to make our charging, our vertiport, as agnostic as possible and allow people to plug in their own chargers to it. So.
And that was kind of a follow-up question. Do you see kind of what we dealt with in the cell phone world? Everybody has this drawer full of these charging cables from years ago that don't fit anything anymore. So do we see a future where we actually have, like you said, an agnostic system that pretty much anybody can actually use? And if so, it's like, are we going to see multiple cables that people plug into that?
Yeah, so I have to rub my crystal ball. I don't really know right now, right? But so again, Beta is very much user-friendly. Like their power requirement is very user-friendly. Their commercial plan is a little bit different than other people's. There are some people who want to be on the ground for 10 minutes and back in the air again, and they want to charge to 100%. You could take that 200 amps and times it by 6, and that's their power demand. And so I say that because that matters for the connector. To his point, the CCS won't even handle that kind of power. And so you're automatically moving. And so to make a standard today would be dangerous, because I think we all would agree that I use the analogy, we're in the 1988 iPhone right now, right? We know this is going to move forward. We know these aircraft are going to get bigger and more capable, and we know they're going to need more power. And so trying to stamp a standard today is a little bit dangerous, because we don't know where it's going to go in the future.
Yeah, definitely agreed. And we were, through the Gamma resource paper, it was definitely focused on interoperability and not a standard, right? So that word doesn't come up like this is the standard. It's more to ease market entry of the aircraft. And I think over time, you will end up seeing different connector sizes potentially for like small, medium, large aircraft, because even something like the Pipistrel is probably not going to carry a CCS connector when they can charge at only 17 kilowatts, right? And then you have aircraft of ALIA's weight range, which are like 6,000, 7,000 pound aircraft, and they're good for a few hundred amps. And then you start to think about things in the not too distant future where you're electrifying 19 passenger aircraft, and then that's like 1,000 amp charging, right? So then the question is that 1,000 amp plane and the 17 kilowatt Pipistrel going to have the same connector? Probably not, right? Right. So then how does that split come? I think we're seeing some variation in the industry based upon business model. There are some OEMs who also plan to be their own 135 and 121 operator. So interoperability is a lower concern for them, right? They're going to own their operations. They're going to have some tenancy at an airport. And there's not really an open invitation for other people to come charge versus like the strict OEM model like Beta has, where we're selling our aircraft to operators. Potentially, they're going to have multiple electric aircraft, and that's where we're seeing the drive for interoperability.
Looking down that path, one of the things we look at is the utility companies that are providing this, quote, power. So, Clint, I know that in California, you've had the opportunity to work in that space, also in Utah. And what are some of the gaps you've seen? What are some of the issues, misconceptions on both sides of the fence when it comes to, hey, we need you to come in here and give us power?
Yeah, so admittedly, I'm not a power expert, so I come in, very, I guess, open-minded, hoping that they're going to steer me in the right direction, in these conversations. And so in this discussion, I'll wear two hypothetical hats, one as a state airport system planner, which is the role I filled in Utah, and then one as an airport operator, which is what I did in the Air Force. And so from those perspectives, obviously, we're looking at the future, and kind of focused on that future and saying, hey, we want agnostic, and all that kind of stuff. And I think, your previous response really helps to clarify, what the road looks like to that. It's not going to be, today we've got no charging systems. Tomorrow we got a completely agnostic system, so we're going to have to start looking at that. And the other half of it is when working with power companies, the challenges that I learned in Utah, which is where I think a lot of, they're more willing to talk to me more frankly, was if you have a vertiport, say, so not even looking at the airport applications, but if you're looking at a vertiport in a downtown area, we threw a bunch of hypothetical situations at them, and they said, yeah, in most situations, the power company is always going to say we can handle it, because even if we can't handle it, we're going to figure out, how to handle it, and we're just going to charge you for it in some way, shape, or form, down the road. And so that's what really caught our ear is that, if we're going to be charged for it some way, shape, or form down the road, what is that going to look like? Well, it depends on, how much you're going to exceed the demand then that facility is going to be capable of, today. And so is that going to require a substation upgrade? If that requires a substation upgrade, is it going to require upgrades to the facilities leading to the facility? And if you're looking at a downtown environment, does that mean that those utilities are going underground, and are we going to have to tear up the roadway, to do all that? And if that's the case, then we're going to sequence that in with other projects where we have to tear up the roadway, so we're not tearing up the roadway multiple times. And so now we're looking at a project that, hypothetically speaking, I have no idea, what it would actually cost, but maybe tens of thousands of dollars to do this upgrade to, possibly hundreds of millions of dollars, because now we're tearing up roadways and doing all that kind of stuff. So that was a big eye-opener. And before I get onto the airport application, I'll just, toss it back to both of you and just kind of, get your responses on that, and just kind of maybe get some higher fidelity from your perspectives on that discussion. Again, at a high level, just someone as a, from the industry, but is unfamiliar. This is completely new territory, and so we're just kind of taking it in as much as we can. And so this is our unrefined, big dumb guy, questions to you.
So, money fixes everything. If you bring enough money to the table, you can make it happen, right? And so we've learned this, unfortunately. I think to your point, no power company says we can't do it. That's what everybody says. Where are you going to get the power? This is never going to happen. The power companies have not been that way for us. It's always been, yeah, we can do it, but there's no substation, there's no wires. So we're putting airplanes on existing airplane patches. There's not this kind of power next to a flight line anywhere. So that's challenge number one. You got to run. We've had to build a substation at one base. Actually, at both bases, I think we had to put substations in. Just one. So we had to put in a substation. We had to run all wires. And oh, by the way, airfield managers aren't pretty excited about you putting things next to a flight line, right? And heights and distances and everything matters. The cube's pretty nice, right? But most of these chargers are 8 foot high. Well, you can't put that within a certain area of the flight line. So there's been a lot of challenges there. So money fixes everything. You put enough money on the table, you can make it happen. We've had, the base has been pretty awesome to work with, the military side, and the power companies. The problem we're having is trying to work with the base and the power company and trying to make everything happen across those lanes is where our biggest issue has been. Clint, yours is probably a little bit different from the commercial side, so I'll let you go.
Yeah, so Jeff brought up a few things there, and so did Clint. I think we've never encountered a problem where we've had an airport or a heliport or a proposed vertiport where we're doing the power engineering and the utility says there's no power there, we're sold out, right? It's usually here's the time and the money to get there. I think right now, one of the, not to give away our strategy, but something to think about is there is a first mover advantage in getting what's left on that distribution or transmission line. So if you're the fourth, fifth, sixth person to try to put a charger in at an airport, that's where you're going to start to run into these capacity issues. From overall grid planning, there's a few things that we see the utilities looking at. One is load factor. So what is your average load to your peak load, right? The closer to 1 that is, the happier the utility is. The closer to 0 that is, the less interested the utility is in your project. So in some of these operators who want to do, a 1200 amp charge in 10 minutes and then maybe nothing else, that's a very poor load factor, and that gives the utility a lot of concern. When we think about delivering power, a lot of people use the term power and energy synonymously, but I think we all appreciate they're very specific and different terms. The grid, so the utility company is responsible for 2 things, the delivery of the power and then sourcing of the energy. The energy is like there, right? And then it becomes an infrastructure problem for power, which is poles, wires, substation. The power portion is going to be sized for peak power, which in most places is like the hottest day in August, right? And then the rest of the year, the utility whole transmission distribution system is running significantly below 50% capacity, right? So then we get into these conversations with the utility on how do we do ADR communication and make it a dispatchable load so the utility can curtail it. So aside from time and money to solve the problems, flexibility in operations with technology can also help solve the problems.
So the secondary conversation that flowed from those initial conversations were, and again, trying to learn this on the fly, so I don't have all the details, but the larger power provider came to us and said, well, here's an example. We had these farms and greenhouses down that needed power, but they were charging at different odd hours of the day, and it was going to be cost prohibitive for them, due to the rate schedule that they were on, in order to do that. But we wanted those jobs, we wanted that, that activity within the state. So we created a custom schedule for them that was, that met our needs, met their needs, and it yet to be determined, if it's going to be something that is going to be supported like that, within various different jurisdictions. But is that some conversations that you guys have all had on, customized rate schedules and things of that nature?
Yeah. So the military's not going to fly at the convenience of the utility, right? So we're going to fly when we need to fly. But I think I'll probably turn the conversation a little bit differently. And I know Beta is one of our partners that we're working with in this space, but we're also working with some other people. So we're really big into COTS, so commercial off-the-shelf type solutions, and integrating them into this space. And so he might hit me or he might smile when I say this, but we're pretty big into the BEST solutions, so battery energy storage solutions, which I think is kind of like taking your scheduling idea, but you're amortizing it over the whole day. So I can load a battery bank full of energy, and I use the analogy of a garden hose. I can fill this battery bank with a garden hose, a very small demand, and then I can offload it in a pipeline. And so as a military, we're pretty interested in this technology for a few reasons. One, they want us to, of course, go everywhere and do an exercise. Well, putting $3 million worth of infrastructure in to do a 1-week exercise doesn't make a whole lot of sense. And so this BEST starts to get us that capability. And then it also starts to answer the military's deployability. But from a commercial side, our team sees it also very feasible because it's also backup power. So if you have a power outage, you're not no op now, right? You can have a power outage and still have 5, 10, 15 flights of energy stored that you can still fly your commercial operations from. It also shaves your peak demands. And so now you don't have those big peaks anymore. You can fly, and there's almost no noticeable demand on the grid because you have the stored energy that's taking up that demand. So.
Yeah, absolutely. And I think, from a retail energy customer perspective, demand charge is the most available expense reduction that a BEST can provide to a retail energy customer. A lot of the corporate customers like expense reduction because you don't get taxed on expense reduction, right? So it's like better than making another dollar profit. I think what Jeff's talking about is what we would consider non-transmission alternative. So is there a way, rather than building a substation, we can put it in a battery to levelize that load, provide energy, do a trickle charge of a large battery, and then use that? So we definitely see significant opportunity for the non-transmission alternatives. And full disclosure, I'm an energy storage guy in recovery. I did that for 10 years, so very near and dear to deploying energy storage systems when there's, like the non-transmission alternatives, arbitrage opportunities for sure. I think it's when people are expecting like, oh, I'm going to put a battery in and I'm going to save all this operating dollars on my retail bill. It can be challenging in certain geographies to actually show a positive NPV on those projects.
And that's the last place that discussion ended, so obviously we got this information and we're intrigued, and this is still a few years ago, so we're unsure, is it going to be government subsidized, is it going to be completely privately funded, yada, yada, yada. And so we wanted to kind of press the test just to get an idea if the state was expected to fund some of this, what it was totally going to cost. And so, we offered up to the utility company, hey, can we give you a hypothetical location, and just kind of run through a scenario desktop, and see what it might cost. And then, yeah, we can absolutely do that, but that's going to cost you around $20,000, to do that kind of study. And so, again, just gauging reactions, is that pretty typical from what you're seeing? So.
Yeah, it depends on the size of the utility. I think most utilities, since they are regulated monopolies, get their profit set on like a return on asset. So again, the more poles, wires, substations they can put in the ground, the more assets they have, the more money they can make, which is usually why the answer is never no, right? They love deploying assets. They love deploying assets that they can rate base, so the ratepayers are paying for it, right? And then some of those engineering design services from the utilities, a larger utility, it might be, and again, depending on the complexity of the location, it could be $0 in 6 months, and some might be, hey, this is a big project, it's 20 grand, and sometimes it might be, hey, if you move forward with the project, we'll credit you back some of that back to the upgrade. But we've seen the power upgrades range anywhere from $0 at a few locations to $119, I think, is the most we've paid so far. And that's usually because there is a decent amount of rate basing that they can do for a lot of the fixed infrastructure. And then certainly we also take a higher position on the transformer sizing compared to the load just to future proof. So usually we'll pay some differential there.
Okay. Can I keep going, Rex?
Say again?
Can I keep going? All right. So then this conversation, so this was all hypothetical. looking at this, looking at vertiports in particular, and just having conversations with one of the larger power providers, within the state. Then we got an actual interested customer at an airport who had a flight school there who was interested in transitioning a portion of their fleet to trainers, electric trainers, just to take over the stick and rudder time, feeling that would reduce the cost of pilot training. And so we were excited to have an actual customer. So we took the lessons learned from talking with that power provider, went to this jurisdiction, which was actually served by a different power provider, much smaller, and we thought we were smart going in there talking about rate schedules and all that stuff. And it's like, hold on, we're not big like them. We don't even have that ability to look at rate schedules. So you're just getting what you get, and you're just going to have to deal with it. And the thing that then they relayed to us was, one of the biggest costs is going to be, actually just putting in the infrastructure, and so the cost per foot of line that you're going to have to run and what it's going to take to run that line, is going to be the biggest hit. And they actually then were able to put some dollars to us to kind of give us an idea of what that was going to look like. And I forget exactly what it was, but, obviously the longer you have to run that line, the more expensive it's going to be. And so that became a part of our decision making. And, you put your list up there, but at this angle I wasn't able to see it, but I'd love to hear your thoughts on that.
Yeah, so we're buying some of those airplanes, and compared to the bigger airplanes, the load is very nominal. But I guess my point to that is you have to be careful who you talk to. Obviously, guys like Chip and myself and Suzanne in the back who are doing this stuff every day, you start to repeat KWs and KWHs and times and how many times a day you're going to charge, and you start memorizing all this stuff, and you start knowing what it means. And so when you hear a 27 kilowatt battery that's going to have a 30% reserve in it, that's probably going to take 20 kilowatts to charge, and so it's going to take a 240/50 amp. When I hear this story, I'm kind of like, I don't know what the big deal is. That's a plug in a wall. That's not a big deal, right? But that's somebody that was trying to get more than they needed, which is also a problem. You want to future-proof. We're in the same boat, but you don't want to future-proof yourself out of the price league, right? So you want to build enough that you can still operate in 3 years and not have to make a big upgrade, but you don't want to price yourself out of the competition at the same time. And I kind of heard that story before, and I think that was some of that. Somebody was trying to super-proof themselves for the future, and they kind of priced themselves out of the market, so.
Yeah, a few thoughts there. Unfortunately, once you're digging a trench, pulling conduit and cables, it sort of doesn't matter if it's a 100 kilowatt upgrade or a 100 megawatt upgrade, right? Like, the labor cost is, and maybe 100 megawatts is a little egregious, but to a certain point, like the cost of doing that doesn't matter, which is why we'll pay something to future-proof. And again, this is like, there's no special formula, because we'll get into these circular conversations of like, well, we want 6 megawatts. We don't have 6 megawatts. Well, what do you want then? Well, what do you have, And like, same with our customers, they might not be able to do 5 chargers simultaneous full power, but they can do 4. And then you start to get into these, well, how much do you want? How much do you have? And finding that balance, like, you probably could make a spreadsheet to do that, but there's so many nuances with the different rate structures, which utilities. Could you do something custom? Which utility would require state PUC level approval to do something custom? So I think it is, you can certainly use these COTS components to make systems, but just given the different like regulated and deregulated markets, the level of autonomy that certain utilities have versus others, like there's not going to be a single solution, and you do need to ask the questions very specifically to the utility, or else you could end up in a situation like that. Yeah.
So then we got thrown a curveball as we, they did the math and determined, hey, we think we can do this. We have identified, a spot on the airfield where it could work, and, so let's advance the conversation to the next level. And as those conversations were going on, then the FBO got involved and says, hey, and FBO contracts vary from airport to airport. According to this FBO's contract, they had the first right of refusal of passing any kind of energy or any kind of fuel, on the airfield. And the way they were interpreting that contract was then is that, hey, if you're going to be building something on here, we deserve a piece of that pie. And so that brought that whole discussion, to a halt. And so, again.
Yeah, so again, military, I don't have to deal with that. But I could bring back up the BESS, right? So the BESS is an option. We're buying a BESS currently that stores 500 kWh, which Chip will tell you that's probably easily 5 or 6 flights, or probably 4 or 5 flights for you guys, maybe give or take. And so that's 5 flights of storage, and it drives. I mean, you can just drive it out and charge like an R11 truck. So there's an option there, right? You could charge this thing off campus and then bring it on and charge airplanes. There's a lot of ways around these things. Again, a little bit different being in the military. We carved out some space, made it happen. But that wasn't easy. We did have to deal with other airplanes and concerns, and I could go on and on about some of those concerns, but I'll turn it over to Chip.
Yeah, so that mobile battery solution is interesting. We're excited to test that in a few months with you guys, weeks, whenever that is. That'll be ready. But we have seen this clause, and I think ultimately it goes back to pass-through provision from a certain fuel provider who was forward-looking enough to, in their fuel provision contract, say any energy, including electric energy, for the purpose of aviation. Sort of the first time we encountered this, we were like, wow, that's pretty cool that, Dead Dinosaur Company was thinking about this. We have been good, or they have been like very eager to work with us in terms of like, yeah, we actually don't have a charging solution, so we can't fulfill that right of first refusal because there's, they don't have anything, so we are partnering with them in certain locations. But I think that you bring up 2 other things on the commercial side, which is the flowage fee and the taxes, right? And I don't know if I just stole your next point, but
2 or 3 points down the road. So I'm going in linear with the story of my experiences. Yeah, but we will.
Okay, so I'll wait till you get there then.
Yeah. Conversation stalled at that airfield. Because of those conversations.
Oh, sorry, Clint. Just one other thing. But even if so this was a flight school, but we have had airports who have wanted to put in chargers, and the FBO maybe isn't a willing participant for whatever reason, right? And they're like, you guys are I make money selling fuel. Slight tangent for a second. No one's showing up in the morning and saying, like, am I going to fly my electric airplane or my Gulfstream, right? They're totally different missions. So usually we can de-escalate that conversation by like, hey, you're not really making money selling 100 low-lead, you're making money selling Jet A, and there's no mission profile right now where someone's like, am I using an eVTOL or my Gulfstream or my Global, right? And then usually you walk them down that and they're like, okay. But even if they're still not a willing participant and the airport sometimes will be like, here's a patch of grass you guys can put your charger on. But there's 2 things every pilot wants to do when they get out of the airplane, and I don't think the airport wants them doing that on a patch of grass, right? So then you still need like some fixed base operation, and this gets back to sort of that decision analysis we look at is like, even if everything's like green, if the FBO manager's like, we're between a rock and a hard place.
Yeah, awesome. So that, conversation shifted from that airport to another airport that then became interested, in all this, which was a part of the larger utility company. And so it seemed like a good fit. There was an interested party that wanted to install the chargers and, start, building a base up, at this airport. This company came to the airport and said, hey, we're here, advanced air mobility, urban air mobility, we're the future, we're exciting, you should be excited too. And because you should be excited, we want prime location on the airfield, front and center, at the terminal, yada, yada, yada. And, the conversation then took a turn of, all right, well, we'd love to have you there. We'd love to have you close to there. But, we lease land, right? The airports, lease the land. And so, the land that, where you want is actually currently leased through the next 15 years. And so the conversation, all right, well then what's the next closest? Well, they just renewed it, so it's at least for another 40 years. All right, well, so where's the land that I can lease the soonest? Well, it's over here in the far corner of the airport. That's going to be up for lease in a couple of years now, and it's prime, ready for you to go. All right, kind of sucks, but we'll take it. Now, going back to the conversation of how far do I have to run the lines and everything. We looked at that. Where's your grid tie-in at? Well, it's completely the other side corner of the airfield. And so then they run the math to figure out how much it's going to cost, and all of a sudden it became cost prohibitive. And so the operator, came back to the airport in the city and said, hey, this is a lot more than what we thought it was going to be. Is there any appetite to help subsidize this? And so that then kicked off the discussions. All right, well, if there is a subsidization, what is the return on it going to be? How are we going to recoup those costs? Which then in many states, nobody wants to talk about taxes. So then we talked about, fuel flowage fees. What's the equivalent of a fuel flowage fee, and what does that need to be set at in order to amortize the cost and make sure that we're not, losing out, and we can answer to the taxpayers, on that. And so, would love to hear your conversation on that.
The military doesn't apply.
Figured you'd say that. Yeah, there's a lot there, so I think it gets back to, even with all the great technology and Matterport 3D scanning, ultimately when we down select to like those 3 airports, we're sending someone from our EPC company to do a site walk after a desktop review. Like, we can measure a lot of stuff, like how long, like where's the closest 3-phase, if the utility company either has that public in a GIS platform or they're cooperative with us. So we can do a lot on what we consider a desktop review, just like right-click, measure in Google Maps, right? But then ultimately you have to go there, and part of that's working. We use a tool, Avaplan, to plan turning radius and movement, ground movements of some our aircraft and a composite aircraft. And one of the things is working with the FBO, like what's your transient ramp flow look like? This aircraft's going to charge for an hour or maybe longer, depending upon what the mission profile is. Because usually it turns out the cheapest place to put power is the prime FBO location, because that's where it's already run to, right? We're well aware that they probably don't want an aircraft parked there for an hour or multiple aircraft while they're charging, right? It's also less expensive for us if we can just trench through the grass and we don't have to dig up a ramp, especially at some of the larger airports where you're talking, 3 feet of concrete. Right? Yeah. So we've gotten into those debates. We've done some new ramp expansions at TTA. We're doing a ramp expansion right now, just out at Raleigh Executive Airport. It's going to be a specific ramp for electric aircraft charging. So we did the Avaplan. It was all for like what we consider pull-in, so there's no ground or pull-through charger. So there's no ground handling required, so you can, just go in forward, parallel into the charger and come out. Jeff mentioned earlier our charger. I didn't put too many pictures, or only in this cover page was a picture. But the COTS chargers are these high, like 8-foot towers, which no one really wants near the ramp. So we spent a lot of time working on the packaging of our charger and getting to a 50-foot cable to make it much better suited for the ramp environment, and then looking at some other subterranean options as well to help with like all of these discussions. Like, we can't have this tall thing there. We need a 50-foot cable. You guys can have it over here. And then ultimately you just have to have some level of flexibility, because it was very challenging like 4 years ago when we started this, when we didn't even have a charger in the ground and no one knew like what an eVTOL was, right? And you're going somewhere pitching this thing that doesn't exist. And a lot of people were challenged to envision what they were going to become part of. I think now within even the larger aviation community, eVTOL, UAM, AAM is, somewhat commonplace, so we don't have to do that. And there's enough of momentum building with the network where we do get a lot of airports who are like, I want to do this. So it's starting to change, but you still definitely run into that.
Yeah.
So I can piggyback on that. So I thought you were asking about the taxes. I don't collect them. So with
you spend them?
Yeah. I didn't want to say that, but we do, just like Chip was saying. Again, we're working with many different eVTOL companies trying to help them, and me and my team, we go to several bases and we do very thorough site surveys, right? Like, we will bring the OEM with us. We'll invite them. The base will show us 6 or 7 different locations. And inevitably, the first question is, where's the power, right? So this is a great location. Where's the power at? How hard is it going to be to get here? And how upset are you going to be when we have to dig up land, and because all that changes everything, right? So that is a very in-depth and very long process, and you don't want to get it wrong, or you want to get it as right as you can get it, right? So, and money is an issue. You do want to make it as feasible economically as you can. So, yeah, we do take that very seriously. We're getting ready to go to MacDill down by Tampa, and we're getting ready to do the same thing. They're trying to give us a set of 6 sites that we're going to go out and inspect and look at and ask power. We probably gave them a 3-page list of things to start looking at before we show up.
So, as you can imagine, my frustration at this point, from being a guy that didn't know anything about power requirements and what this would take, to learning these things as I go, and not really knowing what the right questions were to ask. So I'm formulating an internal checklist as I'm going along, and the next exciting thing that came along was in northern Utah, they recently established an inland port authority. And within this inland port authority, they wanted to spread jobs and encourage economic development in rural areas of the state, which meant the establishment of satellite ports that would be fed, and support the main port. And they wanted to maximize, any kind of novel emission-free technologies, because that was one of the big rubs, with the region is how much more emissions are we going to bring into an area that is prone to inversion and some of the poorest quality air quality in the world, when those inversions are in place. So how are we going to mitigate that? And obviously the response was, well, we want to use electric trucks and any kind of electric logistics, and stuff of that nature. And so we got really excited and said, hey, there's synergy here now. Let's look across the state. If you want to establish, electric trucking corridors, let's see if we can't work in concert with this and find some synergies there by looking at where are the airports that exist along these primary and secondary freight routes, and try and get those on the map to talk to people about that. And the vision is rather than having the electric trucking industry come in, do all the work that you're doing now, doing all the site evaluation, all the research, establishing their needs at a place, and then all of a sudden advanced air mobility and electric aircraft come along a few years later or a few years before, and doing the same exercise, doing the same things, just at the airport. Is there an opportunity for us to work together and not compete against each other, but support one another and hopefully build up more resilient infrastructure and smarter infrastructure within these regions that in rural areas they're already struggling to make ends meet and do things, so they can't over bloat and create more problems to handle than they necessarily need to. And so that didn't really move forward the way that I envisioned it. We kind of got to the party a little bit late, so we didn't get the traction that we were hoping for. But I would love to get your feedback on something kind of, I don't know if it's pie in the sky, but just those kind of things.
Well, again, military, but in the DoD, we're like a microcosm of society, right? And so my team works very close with SAF, Secretary of the Air Force, and we work very close with them. They're doing base electrification for vehicles and those type of modes of transportation. And so we are the air arm of that, and we talk to SAF almost weekly of how do we tie into your electrification, and when you're running a power line, oh, by the way, if you shifted that a little bit to the right, a little closer to the flight line, we would be able to tap off that power also. So in the SAF, again, microcosm of the greater ecosystem, we are trying to work for that singular approach of electrification and how do we do both things and make it all work. So we are doing our part, spending your tax dollars wisely.
Yeah, very similar in the civilian realm. And whether we're working with sustainment or materiel command, they're looking to electrify, or our civilian customers too are looking to electrify ground transportation alongside air transportation. And that's another push towards interoperability of charging infrastructure. Is when a plane's not there, can I charge whatever's meeting it on the ground, right? Because usually the only operation or mission profile we have right now where there's not a ground component is organ delivery to a hospital, right? That organ gets off at the hospital helipad and goes to an OR. Aside from that, everything else that's coming off the aircraft, whether it's packages or people, is then going on ground transportation. Yeah. And that ground transportation is also being electrified, right? So how do we design a charger where one plug of the charger is on the flight line and the other plug of the charger is in the parking lot? That's what we did at Springfield Beckley as a demonstration there, and really starting to push multimodal. It becomes easier when it's a tenant-owned thing like UPS, because then they can have the brown trucks just like drive out onto their ramp, right? So sharing that infrastructure as close as that means, even preferably down to the plug, but if it's not down to the plug, how do we do like a multi-plug charger for fleet charging?
Yeah, and part of the initial conversations that we had did start some talks about microgrids at airports and the opportunity to, I don't think you were here yesterday, but you talked about, one of the challenges with urban air mobility and eVTOLs and where to put the infrastructure for that is they want to be close to their destinations. And so that's the attractiveness of vertiports is you're bringing infrastructure to a density-rich environment. And in Utah, we knew that we weren't going to get eVTOLs for some time due to climatic challenges, environmental challenges. So that gave us an opportunity to look at what are our other opportunities. And one of the things that we explored was the flip side of that. So instead of creating infrastructure in a density-rich environment, let's bring destinations. Let's bring destinations to the existing infrastructure. And work with the planners and so on and so forth to see if we can't, create some synergies out of the airports to create those multimodal hubs. And if we're able to do that, is there an opportunity to establish microgrids that could support that? And again, high-level conversations, with the two energy providers that I talked about. One was, yeah, we're looking at that, but we're not quite there yet. We would love to support it. We just don't know exactly what that path looks like yet. And then the other smaller provider was like, we don't even want that. That's not even part of our portfolio. We're still, again, just trying to, get by today, and at the end of the day, and we'd just love to hear your feedback on that.
Yeah, there's a community down in Florida that sort of is trying to do that, right? Build up a community around a lake and have a vertiport there and try to be as most self-sustaining. It's a little dystopian if you go there, but it is definitely a cool idea. To try to build up these futuristic communities that can be self-sustaining. And I think that's ultimately when I think about charging and electrification, it's on the closer we can generate the power to where we're going to use the power, the more efficient it is just by definition, right? And then the more control we have over the sustainability, reliability, and surety of that power. And so if we can get on-site solar, it's typically, depending upon, again, the state and the regulations, you are typically going to be lower than the utility cost for energy, right? And then if you look at some of the very large utility solars, they're down in 3-4 cents a kilowatt hour PPA range. Now, those are very large solar sites, and we don't have predictability in charging to take that, so you need someone else to backstop it. But once we can get to a microgrid with on-site solar generation, with on-site storage to satisfy on-site demand, that's the holy grail.
Yeah, so I can probably piggyback on that. So in our ConOp, where we're talking about deploying to a forward location where it could be third world power. So again, the BESSes, right? So imagine a C-17 rolls in and we unload a power bank, a battery bank off of that. The beauty of that is, I know I keep harping on it, but I really do see it as a great solution for a lot of problems. When you bring the BESS in, you can hook solar to it, you can hook wind to it, you can hook a diesel generator to it, you can hook the grid to it, you can, hydrogen, a hydrogen fuel cell could power it. You can do a bunch of things with it in a deployed scenario that I'm not energy dependent anymore on a sole one energy source. So that's kind of a beautiful thing of the BESS. It kind of opens yourself up to, I can now bring in any kind of electric and use that. And I can even discharge the aircraft into that battery unit if the mission deemed it. So if that plane landed and we're in a bad way and I need energy, hey, that plane's going to stay here. I'm going to unload that energy from the airplane, and now I have 2 more days of energy to operate until I fix whatever problem I have. So the BESS becomes a very, very useful tool. I think for the military it becomes obvious, but that small power where you're having problems with a small company that can't get you the power, suddenly you just plug a 240, 50 amp into it and you're in business. So it's a pretty neat solution, and the BESS stands for Battery Energy Storage Solution, if we didn't say that earlier. But ironically, it doesn't have to be a battery either. We are working with a supercapacitor also that we're playing around with. So there's a lot of new tech in that world. I'll just piggyback on that. There's also this big question, and you haven't got there yet, maybe I'll say, but what do we do with second-use batteries, right? So once we pull these batteries out of the airplane, because you got to pull them out at 85%-ish, we think. So we pull them out at 85. They're still a great battery. They're probably better than any battery in any car today. What are we going to do with them? Well, we could put them in these storage solutions, and they could be a secondary energy source. So that's kind of where we're going, and I see that kind of playing into that world also.
So throughout the entire discussion, we've been talking primarily about airports. So let's throw a monkey wrench into this. Yep. What happens when we put this on a much smaller footprint and we start putting it in urban environments? And oh yeah, what happens when we put this on a rooftop? Yep. What's that electrical connection look like? What are some of the challenges there?
I'm going to step on my drum again. I'm going to say a BESS, right? Put a BESS on the first floor, run a wire up to the third floor, fifth floor, and you're there. I just, again, your power demands are more reasonable, but some of these other companies are not. And I don't understand how they're going to get that kind of power. And remember, that's the power I'm looking at, 480 volts, 1200 amps. That's for a single airplane, one charging at one time. And so if you had three that you needed to charge and get out, I just don't know how you're going to get that kind of power there. And that's why I see the BESS as a multiplier without having to dig up an entire intersection and roads and all that. So I don't know how you get there without that.
Yep. Yeah, definitely. I think in those environments, stationary energy storage solution definitely helps alleviate those constraints. How do you get power up? I think it depends how far up we're talking. And then certain geography is like, the city of New York is notoriously anti-BESS, right? Like it's just super challenging to get that permitted. There are other cities that are easier to do that with. And then again, can you do solar? Like if you could do solar generation on the rooftop to supply the BESS directly, and then you just need a little bit from the grid, because ultimately what it comes down to is how much copper you're running, how many feet, right? How many pounds of copper per foot, and it's not cheap. And then how many simultaneous operations are we talking from a charging perspective? I think the single FATO TLOF, so no stands, presents its own challenges just from obstructions to have a charger, right? Like where are you, assuming you can get the power to that rooftop, where do you put the charger?
Now, I've had that discussion. It's like, where are we going to put the charger? I said, well, you could always put it under the pad, but that blends itself with some other technical challenges as well as safety challenges.
Yeah, definitely technical. We see it more as ergonomic challenges. So we, have these elevated helidecks. There's one in Springfield you may have seen. So where is that we could do a platform off the side? We could have a hatch underneath. What if it's iced over? What if the pilots just land on it, right? Do you need 2 or 3? If there is a fire event in the BESS and it's underneath the helideck, what's the firefighting means underneath? Now are we talking firefighting on the helideck and underneath the helideck for the BESS, right? So where we are, I think right now in optimizing this, because the technology's there, right? We can charge batteries. And then the question is where do you put the equipment and what are the ramifications of that? And at this point, there's no free lunch, right?
Everything's a negotiation. It's like we never all get everything we want. It's like, okay, we have to find that happy sweet spot. In that space, one of the things we talk about in working with Uber and working with some of the other, we talk about what we have out there now for electric vehicles on the road, and then talking to the folks at ChargePoint, and we were talking about size. It's like, is there such a thing as a charger that's too big? What's the limit? We talk 500 kilowatts, 600 kilowatts. Now, Black & Veatch said, hey, 1 megawatt charger. So what are the ramifications of getting too big in that space? Because then we start triggering things, and it's like, well, there's safety issues, there's power issues, there's, well, how many of those can you have? So yeah, is there such a thing?
Yeah, so me and our team, we talk about this every day, right? So from a charger standpoint, I don't know if there's anything too big, but our question has more been on the side of the battery storage and how much, at what point do you have pretty cool power storage? At what point do you have a small atomic bomb, right? Where's the line? How much energy can you put? Where should that be in reliance to the build, in reference to a building? Those are some of the questions that haven't really been answered yet, and we're kind of going alone and afraid. So we've gone to some of the certifying type organizations. In the Air Force, we have an office called AFCEC. They work with the DoD and they write a lot of these policies, and they pretty much said, "Great question. Let us know what you find out." So, they're also everybody. A lot of these organizations are on the forefront of this. A lot of people are afraid of lithium for the wrong reasons. They are not educated enough to know it. It's new to them, and so we have to educate. And honestly, most of us in this room are probably on the front end of a lot of this stuff, and we're literally we're doing at Eglin. We're testing it, right? We're going to put it on the ground, figure it out, and then tell people don't do that again.
So the largest battery charger that I've personally engineered was 3.3 megawatts. Our charging system is parallel isolated modules, so we have no technical limitation on like how many of those we want to put together. So in the future, as charging demand goes past 500 amps into 1,000 amps or whatever, for us, it's just more and more modules. And then it becomes, well, how it gets back to ergonomics, right? Like that 3.3 megawatt charger was a BESS system. So no one was dragging that cable around, right? Now, if you have a 3.3 megawatt charging cable, like how are you ergonomically moving a 3.3 megawatt charging cable, right? So from a technical perspective, like I'll give you as much power as you want. The two challenges then become ergonomics on the cable, which is going to be, if you did like a principal component analysis, ergonomics and losses are going to be, the vectors are going to be opposed to each other, because we can make a smaller cable, which means it's going to be more lossy, which means it's going to get hotter. Now maybe we need to actively cool the cable. That's only on the power side. On the energy side, the fundamental limitation we run into is the maximum short circuit current rating of DC fuses and DC switchgear.
Yeah, I'll piggyback on that, Chip, because might help other people in the room. So a lot of people think if you charge faster, the batteries are going to get really hot. That's not necessarily untrue. They will warm up, right? But in the case of eVTOLs writ large, that's not even close to the amount of heat that your batteries are going to ever produce, right? So the amount of energy I can push in it to charge, let's just say we charge at 3C, which would be really fast. So if I'm charging a battery at 3C, that's a pretty healthy charge. But we're flying these batteries at 10C or 12C. There's a couple companies that are at 15C. And so the amount of heat that these batteries are engineered to and that they're sustaining is nowhere near the energy that we're pushing through the charge. And that's usually an eye-opener to a lot of people, because they think like, oh, if you charge that fast, the batteries are going to get too hot. It's actually not. I mean, yeah, they'll get warm, but it's not nothing compared to what they're going to experience in flight. So that's kind of an eye-opener for a lot of people, a little bit different than the car-type batteries where, yeah, that's probably the most heat you're going to get in a car is during the charging, but in these eVTOLs, that's just a percentage of that heat.
Can you explain a little bit the 15C, 5C, what that means?
Okay, so first off, my degree is in business, but I did sleep at a Holiday Inn last night. So, basically the way I understand it, 1C is the time it would take to charge or discharge a battery in 1 hour. And then every time you add a C to that, you can divide that time. So if it's 2C, it's 30 minutes. If it's 3C, it's 20 minutes. If it's 4C, it's 15 minutes. And so when you get to a 15C battery, you're talking about the ability to fully charge or fully discharge that battery in about 3 or 4 minutes, which is very, very fast, right? So that is when we say C rating, that's what you're talking about. Did I do that pretty good?
Yeah, that's exactly it. So if you had a 100 kilowatt hour battery, or I'll say it this way, if you had a 100 kilowatt hour battery and you charge it at 100 kilowatts, that's 1C. If you charge it at 200 kilowatts, it's 2C. Charge it at 300 kilowatts, it's 3C. Okay. And then, so each one, you're halving the time. Yeah.
So if we can maybe get into Mythbusters on this, it's one of the concerns that were raised on the vertiport applications, when you talked about the fast chargers and, some of the, the 15 or whatever megawatt chargers. And the cable ergonomics, what does the cable actually look like when you're looking at like trying to rapidly charge an eVTOL, to maximize your turnaround time?
So, their cable, and I'll speak a little bit for you guys, but their cable is a standard automobile-looking cable. I don't think it's any bigger than a standard, maybe a little. The companies who are trying to push the more are using multiple cables, and so they're charging 2 sides at a time. The cable is marginally bigger. It might have liquid cooling in it, and so it's a larger cable, but they get around that by using multiple cables. To your point, nobody wants to lift a 15-pound per foot cable around, and so how do you do it differently? Well, then you add more cables and you charge at different ports, so it goes faster that way.
Yeah, coming from a prior maintainer who's had to drag the cables, push the carts, and do all that stuff, I can appreciate that. But at the same time, now, and maybe I'm just kind of grasping at things here, but if you got multiple cables, that's multiple things to handle in order to get that aircraft ready to depart, which can add time, staff, whatever, onto that. So I don't really expect a response. Maybe you do have a response to it, but just kind of add to the conversation.
Yeah, for sure. So our cable is very similar, almost identical to a EV cable with a few exceptions. So we did a relatively large trade study on liquid cooling the cable to keep it more ergonomic versus passively cooling the cable to keep it higher efficiency. Ultimately, for the current generation charger we're deploying, it's a passively cooled cable. And we got there by adding motorization. So there's a motorized reel that the cable's on for it to pay in and pay out. So if you think of like, just from a force perspective, it's effectively zero force for the user because the reel is pushing it out and pulling it in. So where we deviate from a standard cable is that the standard cables, if you try to push it out from a reel, it's just going to wet noodle. You can't actually like push a wet noodle, right? So and then there's a balance in the stiffness of the cable because you need to be able to push it out so that way someone's not like dragging this few pounds per foot of a 50-foot cable. But then you also need it ergonomic enough so that way someone can like actually plug it in, right? So the best to pay out is the worst to plug in, and the best to plug in is the worst to pay out, right? So to your point, no one gets everything they want. So that's what we had to work on. There are people who are using multiple charging ports. That presents certain unique, very technical challenges. Typically, those people who are using, and I can't say all, but because I just don't know, but the aircraft who we've seen that are using multiple charging ports, and we do support very technical conversations with other electric aircraft OEMs who are interested in using our charger, and we have shipped our charger to a few of them along our line of interoperability, is they are splitting their battery. So within our aircraft topology, our battery is a single master DC plus and DC minus. In their aircraft, they have a distributed energy topology, and that's for redundancy, right? And this, again, there's no perfect thing, right? If you have one battery and that battery goes bad, like all of those 20,000 cells go bad, like you have an issue. In their battery, if one cell goes bad and you have no way to access the energy that's still in it would be like making a twin-engine airplane where you couldn't cross feed, right? And that's also supporting why they need to have multiple ports. The customers who we're looking at who have these very high UAM operations we're doing time studies with them on like, what's the speed we set that motorized reel to pay in and pay out, because what's the turn time for an aircraft? Now, once you're getting to 4 or 5 charging cables, you either need to have 4 or 5 maintainers or line personnel, right, to plug in 4 or 5 cables, or you just go to one charging port.
Gotcha. So yeah, perfect transition, Rex, to talk about the vertiports and urban environments, because that's where my next career, choice took me, was in that urban environment. And yeah, I had all these questions and didn't even really know where to start based off all the challenges I had in these conversations at the airport level. I was trying to figure out what is the challenge within urban environments, and Rex and I talk a lot about that and what's it going to take. But what really, I guess, I spent most of my time in the urban environment was with the permitting processes and what that looks like. And there's a lot of questions around that, and with a lack of standardization, a lack, if the power company utility provider wanted to go and say, all right, well, let's just get an idea of what this is going to look like for us and what kind of lift it's going to be, there's nothing there to reference. And so just curious if you have any experience with on the permitting side at all with the more private applications, non-airport.
For permitting for the vertiport or permitting for the power for a vertiport?
Permitting for the power for the vertiport.
Yeah, I think with the utility company, it's typically coming down to, like Rex said, like, okay, you want this vertiport in the highest density area of whatever a city, and that usually has some challenges from a access to power. The good thing is it's usually really reliable power, right? And then it gets to, well, if we're going to dedicate this much load to you, how much energy are you actually going to use? When are you going to use it? How predictable is that going to be? So again, the utilities never said no. They would love to sell more electrons because that's what they like to do. I would say that in some of the vertiport, new vertiport permitting, we've done the utility, I would say, of all the work streams you have to do. To the utility, it's just a load, right? And they know how to permit a new load. It's all the stuff that Rex has to deal with on the vertiport where, it becomes a challenge with the municipality.
Any issues with lead times? That was something that we had a discussion on, where when you got a very large city where everybody wants to go to, they have to prioritize their applications, and typically private, vertiports, just looking at it from a high level, don't score very well in that prioritization. And so we were looking at potentially 2 years of permitting wait time to get the application looked at.
So for the power side, we haven't seen 2 years. We've seen like maybe 6-8 months in California and New York to get the engineering design package back. And then from that, we can order switchgear and transformers, which right now can have lead time of anywhere from 42 to 72 weeks. So depending on the construction company you're working with, like if it's one of the large ones, maybe like a Black & Veatch, they'll know typically what specs that utility wants, or they might have a standard set already, so we can take some risk and buy that. But by the time you do that whole process, it could easily be 2 years from the time someone says, I want power there, till the power's there.
Okay. Just for record, we put 2 charging stations in 8 months, so.
Yeah, and I mean, you know, you're the government, so you can do. We've executed projects like there's at Rome Air Force Base. They had a lot of power left over because there were some big hangars, and there were a bunch that had 480 volt, 400 amp service to each hangar, and same at Plattsburgh. And we were able to drop chargers in very quickly. There's also a benefit. There can be a permitting benefit if we do the charger in the hangar versus outside, because then we don't have to do 7460s, and it's a lot easier if we're doing indoor work than outdoor work for the fixed installation of a charger.
Yeah, and I'll piggyback for timelines. We ran into a lot of issues for switchgear, and so you can have the best plan, and if one hurricane rolls in, you better make sure you have that switchgear on the shelf before the hurricane comes, because you're probably not going to get it after that hurricane. And that was probably our biggest battle, was locking down switchgear. No more than we'd find it before we could even buy it, it was gone. Yeah. And it was pretty painful for, I think that was also complicated with the COVID stuff, but it was horrible.
Well, I'd like to go ahead with the time we have remaining, open it up to our audience. If anyone here has any questions for the panel, please, by all means, come up. It looks like we may have something online.
Yes, we do. So, are all 6 of the eVTOL aircraft types that the Air Force is going to be flying at the same base, or where are they located?
Yeah, so we're flying one partner, it was just announced, right? We are flying Joby out of Edwards, and we're going to be flying Beta out of Eglin, out of Duke Field. And then we are leasing some aircraft that are going to fly out of San Antonio and Springfield, Ohio.
All right. A grid expert a few weeks back said that there are 2 primary obstacles to setting up charging stations today. One is you're looking at a 2+ year. You're looking at 2+ years for a transformer due to supply chain problems, delays, etc. Next is the power line deliver grid. It will need to be upgraded. This is a huge cost barrier. Maybe you guys have comments on that, or?
Yeah, so that spurred I think it was actually a Duke. We actually ended up putting in a bigger transformer because it was available versus the smaller correct transformer. So that was kind of an awkward thing, but we were able to meet our timeline. So yeah, now they says that transformers were definitely an issue. And I forgot the second part of that, but.
The power lines. So when we're looking at bringing power in, so I always tell people, I said, airports generally have power. Mm-hmm. And a lot of times airports have residual power. So if you're lucky, a heliport actually has 110 volts to power the lights. So when you look at, okay, there is no power there. What's it look like in getting power to a location? There's the permitting for the power lines. What's the cost per mile? Things like that.
I don't know the cost per mile. Suzanne may, but I don't know it.
So we haven't seen lead times of 2 years. We've seen lead times of about a year for a transformer. There are 2 main transformer companies, 3 sort of for the standard distribution transformers. They split. They have each of them has a factory that makes the smaller transformers, which could be like 2.5 megawatts and less, and then a factory that makes larger. So sometimes, depending just on the demand and the capacity, you could get a larger transformer, sometimes cheaper and faster than a smaller transformer. So this gets back to the conversation when you're talking to the utility. If you're like, I want a megawatt, they might tell you it's a year and a half, but you get 2 megawatts in a year, right? So it's just like this weird thing, and we had it happen down in Eglin. But I haven't seen 2 years for a transformer. 2 years maybe till the transformer's placed, but not a 2 year lead time on the transformer. For power, I think we haven't done any projects where there was like no three-phase power, so we had to do like a big, clear cut some trees or run an underground distribute like big three-phase transmission. In an energy storage project I did probably 6 years ago now, it was about $100,000 a mile for three-phase transmission.
Yeah, I'll just piggyback. So
yeah.
typically airfield managers, I think I hit on this earlier, but they're not too excited about you putting an 8-foot charger along a flight line. So that's an issue, and there's usually not 43 phase running anywhere near the edge of a flight line. So that's an issue number 2. So you might have power at a airport, you might have power in a hangar, but if you're going to charge out on the apron somewhere, you're going to be talking to a lot of people. There's a lot of aircraft lighting wire. There's all kinds of radio wires and stuff. They're running through all that stuff already that you got to run 483 phase under, around, over, through, and get it next to the flight line somewhere where you're going to charge at. So that it's not overcomable, but it has definitely been an issue.
Which is why in the AAM 101 I tried to highlight the Part 77 surfaces, because that's where your issues, the surfaces and different zones that protect areas on the airfield, is the issues that you're running up against. And as you can imagine, on a urban vertiport, those surfaces are much more constrained, and so the available space to do things and still maintain those surfaces for safety, becomes very, very challenging.
Absolutely.
Any other questions from our audience?
I guess related to what you were just discussing potentially, how many Air Force bases are in line to receive electric chargers as part of this phase of Agility Prime?
So in line, so it's really, right now we're testing at Eglin and Edwards, and we've been discussing opportunities to upgrade those 2 areas. But funny enough, they just broke ground at Eglin, and they're putting that stuff in right now while we're speaking. And then in a month we're going to MacDill. So it's really right now, Special Ops is kind of looking at this aircraft for obvious reasons. It's quiet, and so that's why we're going to go to MacDill, talk to those folks. And then there's rumors that we might go maybe to DC next, for DV transport, those kind of things. And so we're on demand, I guess, right now as commands come to us and tell us where they want us to go.
Next question.
You guys mentioned a lot of big numbers when it comes to electricity. Is there any safety issues for ground personnel handling this type of power?
So I'll go first, and then so definitely. I mean, but there's safety interlocks, especially like the CCS plug. It locks, and you can't unplug it, and you got to hit a button usually to unlock it. So there's safety interfaces in that where it'll automatically cut the power when it senses a communication line disconnected. But those are AC powers, and they still hurt. 30-year aircraft aviation guy, aircraft mechanic. So I know that AC hurts, but DC will kill you, right? So DC is where the real danger is, and there is DC on these plugs. There are safety mechanisms on them, but the real concern right now, of course, is the actual batteries, where you're talking 800-volt DC. That's where people are worried. And we didn't talk about this at all. And in fairness, it's not really an issue for Beta, but some of the other vendors want to be able to discharge so they can't change their batteries. So Beta can drop a battery, and they can put a new battery up. So there's some DC issues there, which I think they've solved, and it's not really an issue. But there's other companies who can't do that. Their batteries are of course they can change them, but it's a major maintenance function to change batteries. With those batteries, they want to be able to discharge into the grid, and nobody's thinking that. That's actually probably one of our biggest issues, is having people allow us to discharge into the grid. But back to your point, safety on the batteries is probably where the bigger concern is, because that's probably where somebody's going to get hurt if they're not careful.
Yeah, the chargers domestically are for safety. There's a lot of effort, engineering effort, design effort, just from paper analysis like FMEA, DFMEA analysis, to understand the failure modes and how those could create hazards to operators. and potentially impact reliability. All of the chargers do get tested to a UL standard 2202 and 2231, which has very extensive testing for personnel safety using EV chargers around ground fault detection, isolation monitoring, to ensure it's a very safe operation. That is one of the reasons why there are a few electric aircraft that are doing battery swap as a means of charging. So they don't have a charging port. A maintainer has to go remove a battery and bring in a new battery. That is probably a very high risk charging. Like if I had to do a job hazard assessment, that would be much higher risk than an insulated connector. Also much longer time, and now you're paying someone, you have to pay an A&P because swapping out a battery on an aircraft is a logbook entry, right? So it's not some aligned person anymore, it's an A&P.
Yeah. Any other questions?
Are you considering dual use for cars as well as planes, and how is that designed to take place at a location in consideration for it?
Are you specifically referring to the aircraft or for the charging?
Both for the aircraft as well as cars. As they come up and park nearby, they can charge and kind of share the cost, and maybe the municipality shares in the build out because of that.
Yeah, so our charger topology, we have a power tower which is doing the AC to DC rectification, and then we do underground distribution to the dispenser. So the dispenser is where the actual plug is. We do have the ability to have one power tower feed multiple dispensers. So this gets back to just the efficiency of commonality with infrastructure. And one of those dispensers could be flight line, and one could be in the parking lot. That's what we did at Springfield. So
Charge my truck there.
Yeah, nice. Yeah, so that's definitely, definitely something we're tracking and currently implementing. And it could also be, you know, if we're installing these hundreds of kilowatts of chargers, the FBOs or the airport or the municipality usually say, hey, what about a level 2 charger, which is like, you know, your home charger for an EV. So we can put those in, and those are compared to the cost of the high-speed charger. They're like within the contingency budget for the construction, right? So we'll usually end up putting in a few of those as well.
So I have a question for Chip. Put you on the spot here a little bit. So because in my team we're having this discussion, but you know lately the DOT, I won't say the DOT, right, but the vehicle OEMs have made this landslide shift to NACS.
Yep.
Is that a conversation where you guys are? Some of this is for my own edification, right? So we were with you. We're going down the CCS route as the majority.
Yep.
I mean, knowing the specs, to your point, the CCS limits you to 500. The NACS does give you the capability of 1 meg.
Yeah.
Are you guys discussing that?
It's a good question. I have 2 slides that address this, but I didn't know if anyone would ask it, so I didn't include them. So I think you have to ask, why are people going to NACS? And it's sort of, I hinted at it a little bit early on, but it's not actually a NACS for CCS conversation. It's an access to a reliable charging network. So, and what everyone, like, how many people here drive an EV? Teslas or no? No Tesla? You drive a Tesla? Okay. Okay. So have you charged on like ChargePoint or EVgo or Blink? Electrify America. How reliable are those chargers? Okay, hit or miss. Yep. Yep, sometimes they work, sometimes they don't, right? Okay. How reliable is the Tesla supercharging network? 100%, right? They could be faster. Yep. Okay, so hit or miss, sometimes they work, sometimes they don't. On Electrify America, which, you know, got a lot of government money to build out that network with really no KPIs that they had to maintain to keep the network, versus Tesla, an OEM deploying a charging network that always just works, right? That is why people are moving to NACS. Had Tesla developed CCS and NACS was the public standard, people would be going to CCS away from NACS because it's not, the average consumer doesn't care. Like the plug, yeah, the NACS is a little bit more efficient. They use AC and DC on the same pins, so it's like a slightly smaller form factor. Supposedly you can get a megawatt out of it, but like the temperature tests on that are a little questionable, right? But it's not about the shape of the plug, it's about reliability to the network, because Ford, Rivian, they all recognize that if they have to rely on Electrify America, where sometimes it works and sometimes it doesn't, like you can find all the horror stories if you read on PlugShare's webpage, like we were trying to go to a concert and we missed the concert because the EA charger was broke or the Blink charger was broke. You don't read that on the Tesla chargers. Right. So in our opinion, and this gets back to our motivation for the charging network, is if we relied on Electrify America or some third party to deploy charging infrastructure, and then we had operators calling us saying, I'm AOG because this third-party charger's not working, it erodes the whole value proposition for aircraft, right? Right. So I don't know if that answers the question. But.
Well, you went around, but you're not considering going
to
NACS.
So sorry. So I guess I'll direct it. We're not considering going to NACS because there's not a technical benefit to going to NACS because it's not like there's superchargers flight line side, right? If all of a sudden there were 1,000 superchargers flight line side, like maybe we consider it. Now we're beholden to, Elon's mood of the day for us to be able to charge there. So maybe that's still, there's a business risk decision there as well. But we're not considering because we don't see a strong technical benefit to doing that or commercial benefit.
Can you give a quick, 1 minute description of the CCS versus NACS and what they are?
Sure, yeah. So NACS is the Tesla standard. It's North American Charging Standard is what NACS stands for, and CCS is the combined charging standard. The main benefit of NACS versus CCS is the NACS plug is, I should know the number, but about half the surface area of the CCS plug, and it's because the CCS plug has 2 pins for AC charging and then 2 larger pins for DC charging. So if you look at the CCS plug, there's the round section up top and then the oval section underneath. The oval section underneath is the DC and the round section's the AC, so the level 2 chargers plug into just the AC section and the DC chargers plug into both for communication and power. With NACS, Tesla uses the same pins to send both AC and DC power, so they remove that oval section on the bottom. So it is a slightly smaller, or about 50% smaller surface area. The NACS standard uses CCS communication, though. Yeah.
Well, I think we're just about out of time here, so if there's any final questions, now's the time to ask.
So this is a plug. We have the Transformational Vertical Flight event symposium in the San Francisco Bay Area in February, and we offer an eVTOL short course. It's a full day, and we talk about charging, and we talk about everything electric aircraft. And Dr. James Wang from NTU in Singapore is going to be teaching that. So if anyone's interested in learning more about charging, or it gets into the weeds, if you're an engineer, you're going to love it, but it's also broad enough where anyone can enjoy it. So that's the course we're offering, Vertical Flight Society course in February.
Excellent. Well, I would like to say thank you very much for our panel. Again, it never fails. We get deep in the weeds and cover a tremendous amount of territory. So give our panel a hand. Thank you so much. So with that, I will wrap up our 3-day event. We will probably be sending out a survey to everyone that attended to find out, hey, what did you like? What didn't you like? What would you like to have us discuss next time? What are the things that no one's talking about? So look forward to seeing that survey come out sometime in the next couple of weeks. All the stuff that we did was recorded, and we will have that on the Vertical Flight Society site. As a registered participant, you have immediate access to that as soon as it gets published. So with that, thank you, safe travels, and I can't wait to see you all again soon.